Okay, we're going to go ahead and get started. Hello, everyone. My name is Dave Nielsen. I am a co-conspirator of this meetup group with my friend Max and Alexi, who's out gallivanting somewhere in Europe. Turkey. There you go, in Turkey. So thank you for coming, and it's great to see some familiar faces. I also see some new faces. How many of you have been to this AI agent meetup before? Raise your hand. Okay. Gosh, a lot of new faces. Okay, well, that's great. All right. Well, I just have a few housekeeping items to share with you, and then we're going to go ahead and move on to our talks. We have count them, 5 talks. We have 2 lightning talks, and then we have 3 main talks. And of course, tonight the topic is AI agents in production, which is sometimes an elusive idea because everyone's building things, but the percentage of people deploying into production, not so much. So we're looking for those kind of, we will always take those kind of talks seriously because, as they say, well, I won't, it's a curse word, I won't say it. But thank you again for coming, and let's go ahead and get started. One last thing I was going to share with you is that I work with the AI Alliance. So I'm the head of the community for the AI Alliance. And if you haven't heard of the AI Alliance before, we're an organization that was founded by IBM and Meta, 2 very different companies. And we both have a lot invested in open source and AI. And so that got us together to help promote and support the community and businesses and everyone really who wants to use AI using open source. And so what does that mean? That means that we have technical projects we work on. We also get involved in like best practices, and we get involved in sometimes sharing our opinions on government policy. And so we have an arm of the Alliance that does that kind of work. And but what I want to share with you is we have a new project that's coming up called the Open Agent Lab, and we are inviting folks to, if you're interested, reach out to me because we haven't published it yet. But in the next, I'd say in 6 weeks, I expect we will publish it. And the invitation will be if you have a project that you're working on that is either building an agent, building tools for agents, building MCP servers, building any of the capabilities to support either of those, we would like to talk to you and support you. And what does that mean by supporting you? We're talking about having a project where we get various tools, different projects, and we work together to integrate them with each other. So if you have something new and somebody else has something new and you want to see how they work together, then we'll help play matchmaker, okay? And that might mean simply like there's a new framework or a new platform, and we'll find somebody who will help you onboard to that new framework or platform and support you to help it work. A lot of times when things are new, it's hard to try it out if you don't have somebody to answer your questions. So we want to find people who can work together and answer questions. And who knows, we might find gaps. Our purpose for doing this is we think there are lots of gaps in the way that agents are going to work in open source that are not working today, and we want to identify them and fix them. Okay? All right. So that'll be called the Open Agent Lab. And also put on your calendar Tuesday, September 16th, right before the AI conference, we're going to do an unconference where we're going to let people come and share all sorts of different topics that they want to discuss. And we'll break out into lots of different rooms. And instead of having PowerPoint presentations, it'll be a conference of discussions. Okay? So that'll be September 16th. All right, so with that, I think I can move on. Here's just a list of some of the projects that we're currently working on at the AI Alliance. As I mentioned before, we're very interested in MCP. In fact, a new project that we're working on, it's not listed here, I don't think. No, it's called Context Forge. It is an MCP like registry and gateway. And that's a new one that I'm interested in. Just to mention a couple others, the OpenDXA is a new project where they've basically created a new programming language that is based on Python, but what it does is it has AI built into it. So when it discovers errors, or you can actually just ask it in the language itself to go solve problems, and so they're kind of building AI into the language, which is very interesting to learn about. You can expect that would be how things would be in the future, right? There'd be languages that just kind of have AI built in. Okay. All right, so with that, let's go ahead and move on to our first speaker, and I'm going to let Max, is there something else you wanted to say?
Yeah, let's see.
Okay, here you go.
Yeah. Actually, these are all good things. So one is that I take pictures for this event. If you don't want to be featured in the photo, just give me a little nudge and tell me I don't want to be there, and I'll try not to include you in the photos. But I can promise it's going to be decent photos. So that's one. Second thing is to announce the topic for the next month, and it's going to be AI in the workplace. So basically AI taking your job. AI agents taking your job, or maybe assisting you, right? So, and the last thing I want to mention is that if you have a talk, certainly for the next one, then make sure you try to chat with me or with Dave so that we can definitely consider you, because we want this to be for the community, and we want to at least include a talk that came from the community every single time. So find us. So with that, back to you, Dave.
Well, actually, I was going to turn it right back over to you, but I do want to say one last thing is this Open Agent Lab. All right. By the way, every time I say it, I keep getting this song stuck in my head. I don't know if you guys ever remember an old song, Secret Agent Man. It's every single time I say that song is in my head. Anyway, so we are thinking about not only having this be an online group that gets together once a week, but was also thinking about getting together in person, in San Francisco. And I'm just kind of curious, how many of you actually are based here in San Francisco? You would think, right? Okay, good. At least half of you. All right. And of those who are nearby or local, I would like to know what kinds of things you would like to get together to work on. As I mentioned before, it could be different projects and how they integrate and work together. It could just be demos. But with all that single purpose of getting these technologies to work together with maybe registries, this kind of thing, there's different projects that are working on these different areas. But I was kind of curious, how many of you are interested in a technical level of coming to a workshop maybe once a month or maybe twice a month, where we have somebody kind of demo this kind of stuff and then you can try it out? How many of you would be interested in that? Lots of hands. Wow. Okay, this is super cool. I love that. All right. Thank you. That's very motivating. All right, so with that, let's turn it back over to Max, and let's get some more motivation.
Really quick.
Show off. Yes. Secret agent, man. Awesome. Okay.
Yes. All right. So as Dave mentioned, we have a really good lineup of speakers, so let's get started. The lightning talks will be about 7 minutes, and then the full talk will be 25 minutes with some time for questions. If you have questions, just be ready to ask. So the first speaker is Marquita Ellis. She's a research scientist at IBM, like me, and Dave is also part of IBM. And I don't know what she's going to talk about too much, but I can tell you very quickly that she's part of a group that I think is awesome, where they work with different universities. This includes Cal Berkeley and Stanford and other places. And they try to basically bring research closer to industries and industry closer to research. So with that, I'm super excited to hear what Marquita is going to talk about. I'll give you Marquita.
If you're in this room, you have noticed the proliferation of agentic AI across domains of science, enterprise, and beyond. And these use cases are not limited to single modalities or single models, but include multiple modalities of data and foundation models. And you have probably contributed significantly to that proliferation. You're probably also keenly aware that going from a capability demonstration to an impactful, deployable agentic AI system is not separable from latencies, cost, security, and many other concerns. Am I right? I think I'm right. So I am announcing an opportunity for you to share your progress and your pain points with leading researchers across AI, security, scalable data systems, and other computer science domains. Now, currently, this is a collaboration of over 20 researchers across Berkeley, Stanford, IBM Research, Intesa Sanpaolo, and UIUC, thanks especially to our collaborating faculty, Matej Zaharia, Don Song, Kaushik Sen, Joey Gonzalez, Jan Stojka, Daniel Kang, and their phenomenal students, many of whose names you'll recognize from their significant contributions to open source agentic AI. And you can start participating this minute, actually, by scanning either the top QR code to answer some really high-level questions while you're multitasking right now, or by scanning the bottom QR code to share your contact information for an in-depth discussion of your use cases. Now, who of you thought tonight that you would be participating in some cutting-edge research from the same faculty who brought you VLLM, Chatbot Arena, the Berkeley Function Calling Leaderboard, Ray, Spark, MemGPT, and countless other projects? No. Well, let me tell you a little bit more. This is a study in progress of production track agentic AI systems, in which we are taking a closer look at what is working and what is not working, and why or why not, in practice, attempting to bridge capability demonstrations from academia with production system realities from industry. And as a first step, we are synthesizing published literature, open source code, blogs, with questionnaire and interview responses from experts such as yourselves. So if this vision of cutting hype curves to focus on agentic AI systems of impact is appealing to you, scan the QR code. And you have questions, anonymous feedback, references you want to share to promote your work, you can do that by emailing me or using the QR codes. We would be happy to discuss forms of appreciation. If you do want to de-anonymize, you don't have to, but if you want to, we can discuss ways to appreciate your input that are in ways that are meaningful to you. So to re-summarize, we are seeking to characterize agentic AI use cases from production track case studies to bolster the foundation for research and development of efficient evaluation, runtime, programming, debugging, and other supporting systems for agentic AI. So if you are using the word AI agent or agentic AI to describe your work, we want to hear from you. Thank you.
Yes. Okay, thank you, Marquita. And just to add a little bit to what Marquita was saying is at Cal Berkeley this weekend, the same group that she listed here had a really cool conference on agents. If you didn't get a chance to participate, maybe next time. And it was awesome, like all the professors, and she didn't mention, but like some of the guys listed there were the people that created Databricks. We don't have to keep telling how cool Cal is, but you know. So Marquita is working with them, so talk to her. All right, cool. So next speaker is Ricardo. And Ricardo is one of those examples of a speaker that came from the community. So at the last event, after we announced that we are looking for speakers, he came to me and said, hey, I have something cool that I think would be perfect for agents in production. And we started chatting, he sent me some details. And before you know it, we've met like 2 or 3 more times. And you're gonna see is he's pretty much putting agents, voice agents in production, and has been doing it for a long time. So hopefully we'll get to share some lessons learned and some tips. So welcome, Ricardo.
Thank you, Max. Thank you. Yeah, let me see if this is working correctly. Perfect. So yeah, thank you very much for to the AI Alliance, to Max and Dave, for giving me the opportunity to talk here to you guys. As he mentioned, I was in the last meetup, and well, this one is about agents in production. So I think we have a little bit of experience in that, so we wanted to share a little bit with you guys. So as he mentioned, my name is Ricardo Marín. I am co-founder of Vozy. We are a voice AI platform for the enterprise, mainly focused on Latin American market, disrupting the contact center space. We have been doing this since 2018. We have built our own stack. Now we have implemented a lot of generative AI into our product. And we have some learnings that we wanted to share in terms of how to build or implementing agents into production in the enterprise specifically. So let me give you guys a little bit of context of what we do. Basically, I'm sure that everybody here has had the problem, one of the main big problems of customer service, which is being stuck on the phone over an hour when trying to reschedule a medical appointment or change a flight. And that's a very universal problem. Companies spend around $1.5 trillion annually on solving that bad customer service, and most of them use contact centers. And agents in those contact centers are spending 25% of their time basically on repetitive tasks and not solving complex customer problems. And that leads to basically nearly 1/3 of all customers must contact support multiple times for the same problem, which leads to a lot of customer attrition and high operational cost. So basically what we have built is a platform, conversational AI platform, that enables enterprises to design, test, and deploy their generative AI agents over text and phone to automate any kind of conversation. But we don't stop there. We also give human agents real-time recommendations and step-by-step guides on how to solve a customer requirements. Also, through our speech analytics technology, we ensure that companies have 100% coverage of all interactions, so our clients can have a very good visibility of their customer service line over with all their clients. So basically, when we have deployed agents in Latin America, basically, we have seen that there is a huge gap between deployment, a pilot into, there's a deployment gap between pilot and production. And we think that it's mainly because of these 4 key factors. First is basically legacy integration. So 86% of companies needs infrastructure upgrades or software developments to integrate with those AI agents. And that makes it very hard. That means that companies are not AI ready, ready for deployment of these types of AI agents. Also, we have found that there is a lot of uncertainty in ROI. Basically, 80% of companies say that they're willing to deploy generative AI agents within the next 2 years, but we have seen that spending keeps spending is small, and that's because executives are not seeing a clear ROI for AI projects. And as well, basically there is a lot of failure, a lot of fail rate in terms of deploying the AI agents, because traditional AI projects, basically generative AI agents, not so much, but from what we have seen, traditional AI projects have been very hard to deploy. They haven't seen the light of day. So that makes as well a lot of executives very skeptic. And lastly, basically all the enterprise grade security is really important, even the pilot phases. Now we have implemented 4 key strategies for this type of challenges. Mainly what we have done is that basically our first strategy is to find a standalone use case. In our case, and this is something that I suggest to all of you in your projects and in your companies, is to find a use case that doesn't need a lot of integrations, that serves a market, obviously, but especially that you can show a clear ROI. In our case, was payment reminders or collections. That's basically a use case where you can implement in 2 weeks that has a clear ROI, that it's very clear to the business people, and most importantly, doesn't need any kind of integration. So that lets us, that was kind of like a Trojan horse use case, in which we got into these enterprises, and then we started building from there to try to get bigger use cases, inbound stuff, customer service, frequently asked questions, and also building integrations that made us mission critical for them. Also, our second most important strategy was to deploy forward deployed engineers to actually work with our clients' team. Technology adoption is something, it needs to be human guided. It's not just about products, tools, it's about as well as holding the hand of these enterprise companies and guiding them through step by step of the process of deployment. They need to feel part of the solution or part of the project. They need to feel that they're also adding up, and eventually they will trust that you are able to do what you are telling them. The third one is regulatory compliance from the beginning. This is not something that you can retrofit. I have won several deals just because we are fully compliant. We are more expensive, yes, but we are fully compliant. So that makes us very different and makes us very trustworthy for these companies. And the last one, I think, is one of the most important ones, which something happened to my computer, sorry about that, is foster trusted partnership with every stakeholder. Basically, enterprise deals are not deals that can be done easily through a DocuSign and that's it. It's just, you have to be there, you have to foster good relationship with everybody that can take a decision. And as Jason Lemkin, the founder of Saster, said, you have to get on the jet. If you want to sign a $2 million or $3 million contract with a company, you have to do it by shaking a hand. It's not something that you can do basically just sending a DocuSign document, right? So that's basically what we have found. We have been deploying more than 500 agents over 15 countries. We work with around 120 enterprises in all Latin America, automating around 400 million interactions, more than 140,000 calls. That basically sums up and confirm our strategy. And that's it. If everybody has a question or would like to discuss it, thank you very much. We can see it later.
Thank you, Ricardo. Excellent. So we're going to get a little bit deeper now. And it's a pleasure for me to welcome James Ellis from Solo.io. Anybody here heard about Solo.io? Okay, I know your work for that at the end. So I have not a big story about Solo, but the founder, Edith Levine, I know from my time spending at Pivotal Cloud Foundry. She was building her startups in Cambridge and would work with us. And then eventually, after starting different, try, and most of you here, if you're doing a startup, you know what it takes. She ended up doing Solo, and Solo has been on this rise like this. I don't know the details of their finance, but I can tell you that a lot of our good people went there. So that is good and bad, I guess. But the other thing also is that if you're in the Kubernetes community, you'll know that they've been instrumental very quickly as a small company to get Kubernetes in production, especially things like the network plane and a lot of other things. And they're starting to get involved in agents. And James is going to talk to us about this new project called Agent Gateway. And I guess it's implemented in Rust, so maybe it's very fast and efficient.
Yeah.
Thank you, James.
To flesh out the description there, yeah, Solo's been doing networking stuff for as long as it's been around, 6+ years. We are 9th largest contributor to CNCF. We have the co-founder of Istio as one of our engineering CTOs, Louis Ryan, and we have John Howard, who built a lot of this, is one of our principal architects. So we know that space very, very well. and I'm going to speak a little bit about Agent Gateway. But who am I to tell you anything at all? I am a principal solutions engineer here. That is a fancy way of saying I get brought in to build things into production. And that is where I live. Prior to this, I was a staff SRE. I put Istio in production. I've worked for large companies. I've worked for federal government. I live my life in production. I've held a pager for a very long time. Thankfully, I don't have to hold on to one at this job anymore. It's great. I got a 6-year-old son at home, and I don't got to get called all the time. But so I'm someone that has to deal with practicalities. I don't deal with the theory of running an agent. I don't run the theory of running an LLM. I need to make it work. Otherwise, we don't make sales. We don't. This is a company. That's where I live and die. So that's what I do. I put Istio into production in a lot of places, and as of late, I've been working with more and more partners that are moving into the AI space. And I can tell you there is a lot of fear and there is a lot of trepidation, mainly around security and understanding and governance. As an antidote, yesterday I was on a call with a $4 billion company that is probably on half the laptops here. And they implemented Bedrock for all their developers. Great, right? Some of their developers ran up their bill so high they immediately had to turn it off. They had no governance. They didn't know who or what or why. There was no security control or observability in place. That's a very common refrain for service mesh stuff. So what is Agent Gateway? Agent Gateway is an open source project. It's built to be an AI native, ingest and consume agent-to-agent connections, MCP, and LLM. That is a fancy way of saying, in practical terms, it's a gateway to control, observe, and secure your AI work. So when we talk to large companies that are, again, fearful, their big fear is, what if an agent can do do things I don't want it to do? Exfiltrate data it's not supposed to get to. What if I have a bad actor? What if you're like a lot of companies and you have a developer that checks in an API key they're not supposed to? Cough, half the companies I speak to. Those are all things that need to be understood and alleviated before large companies will move into production. Like, that is the gap we see. And there's a lot of gaps in any environment that moves as fast as this one. There will always be these gaps. And really what this means is, Agent Gateway is designed to let you run your LLM workloads, agnostic of what's running below it, whatever MCP tooling and however you want to chain it together, and any kind of A2A and whatever agents you want to have below that gateway. Now, what is this key features? It is open source. Solo is an open core company. We do not turn around and turn our repos private like some of the other companies have. We are huge contributors, as I said, to a lot of different projects. This is Apache 2.0 license. It is platform agnostic, which is a little strange. Most gateways you'll see are run specifically in Kubernetes. This can run in Kubernetes, can run bare metal, run on this laptop in a demo later, doesn't matter to us. It is LLM and agent agnostic, and what I mean by that is we can connect it to OpenAI, Gemini, Bedrock, whatever else you want underneath the hood, your own RAG, where you're running Llama locally, whatever you want to do, it doesn't really matter to us. Same thing for whatever agents you want to connect to. And we're basically applying a layer above those, so the way you build your application and the way you interact with them is consistent. It is also highly performant. Yes, it's written in Rust. I don't know where he went. I like Rust. I like Rust just fine. Do I like programming it? No. Thankfully, I don't have to anymore, but it's very, very good. Yeah. I mean, Golang's great, but I mean, what we're replacing for the most part is written in C and Java. So like, at least we're making good progress in a direction, right? Now the question is, it is called Agent Gateway, and what you see broadly in the industry, even from us, is people are extending existing API gateways and tacking on AI functionality onto them, which is great. However, this isn't a small change going from, hey, we're changing the way we interact with REST, or REST API. This is a huge shift. I've been around for a long time. I remember what it was like to move to the cloud, huge shift. I remember what it was like to move from just running Nginx and Apache to running things like Envoy and an API gateway. We're in the same spot again. The things that the existing systems like Envoy and Nginx do are wonderful, and we will continue to use them, but they are not designed for running agents. They're not designed for multiplexing. They're not designed for a lot of things. And Nginx didn't evolve into Envoy. Envoy didn't become an API gateway overnight. Those are things that happen over time, or they were just massive shifts in general. So it is unlikely that we'll get to a point where all the things that we want to run to make us safely understand and run AI workloads in production is going to spawn into Envoy. Envoy is a very large and robust community, and we're asking for a ton of change. Also, how many integration-specific gateways do you want to run? Do you want to run a gateway for your LLM integrations? Do you want to run another gateway for A to A? Do you want to run another one for an MCP? No, you don't. You don't want to run a ton of gateways just for that. It's much better to have a simple system that controls all those. And as I said, AI workloads, they have very specific needs. Multiplexing is a complex system that is not readily available in most gateway systems. Same thing for MCP auth, multi-model failover, be able to push calls to agents and then have them respond and push calls back. Most systems are not designed like that because they're designed for REST calls. All right, so great. What are you doing that's unique? So we have deep protocol awareness, MCP and A2A, and because we've kind of obfuscated above those, if there are other protocols that come about, I know there's others that are being worked on, we can integrate those. Your interface will still be the same. And the way you control that will still be the same. Your observability and security will still be the same. But however you want to connect those downstream later will evolve with that space. Fine-grained traffic policy controls. We have the entire Kubernetes Gateway API spec in place. I know I said it's platform agnostic, but just to understand, if you don't come from the networking world, what that means is things like controlling routes, retries, rate limits, all those things already exist inside of Agent Gateway. You can go and check the examples now. We're fully compliant with that spec. And really, that's something that people want from the current API gateway world to apply to what they want to do with AI workloads. And that gets you into a space where you can control with a great deal of of fine detail. You know, how many tokens can this one system use? What is this allowed to chain to and not allowed to chain to? What can this call? What can this not call? What level of auth does this need? Where does it need auth against? What do we do with JOT tokens? All these other kind of controls that are around security and understanding what your traffic is doing and have been in place in API gateways forever are also present here for your agents. Full open telemetry, support for metrics, logs, and distributed tracing. If you're coming from the observability world, you've seen those three things a billion times. I will note, particularly here in both metrics and especially in tracing, this is a little different for AI. In metrics, generally you will want to keep track of what your tokens are doing because you want to keep track of cost. And that's something that Agent Gateway can do, but most API gateways aren't necessarily designed to do. Distributed tracing is also a very interesting space. Most distributed tracing comes from the need to understand what happens when service A calls service B calls service C, and how long it takes, what the return time is, which service is having a problem, right? In the AI space, that is still true, but it's also very true to understand what your cost is when you're calling agents, because you need to know what they call to understand what they're doing and what that calls subsequently. Is it doing another return route to another agent? What all the steps there are doing? And if you're used to that space, you're used to seeing Jaeger and Zipkin traces. Now there's things like Phoenix and a lot of other systems that are designed to give you a really clear understanding of what that is. And that really is the gateway to observing and tuning the systems that you're going to run. One of the problems with running on something in production is you need to understand what it does and when it fails. And that level of tracing is I think, more needed now in the AI space than it has ever been in the service space, because the service space was fairly linear. You had a return call, you knew how many milliseconds it took, and maybe you want to dive in and make a flame graph off the actual service, but that's about it, right? But for running an agent, you really want to know all the things it does downstream. And then the LLM gateway. This is something, there are some other systems that do this, but there is the OpenAI spec. Sorry, I keep on saying OpenAPI because I've gotten so used to that, but there's the OpenAI spec. And so long as you're calling that OpenAI spec, we can do subsequent calls to whatever LLM you want to run it under. So you can connect to OpenAI, you can connect to Gemini, you can connect to all these things. And when they have failures, or you maybe run out of tokens on that service, or there's a reason why you want to switch out, one of the common requests we get from very large customers, like T-Mobile asked for this, is, hey, they really want the ability to switch between ChatGPT models on the fly. If they have a question that's coming in and they know it's simple enough, they either want to hit a cache or they want to hit the cheaper model, right? And so long as they're hitting a consistent interface, you can design this to hit whatever model they want underneath, whatever LM they want to set up underneath, or in theory, you a cache. This is all around, like their need is mainly around cost cutting, but there's also around reliability as well. If there's a reason why Bedrock is down and you have a Gemini account, you can run this stuff through Gemini, right? Things like that. Like having that kind of consistent interface means that your applications can stay the same, and maybe you change cloud providers, maybe you change that underlying LLM, it doesn't matter to you. And the last one is inference routing. This is mainly for companies that are bravely buying their own GPUs in our current market and building out their own RAGs and models internally. If you're going to have queries that are hitting those, they're probably the most expensive queries your company has. And you really don't want to send queries to those endpoints if there is a cheaper alternative or a cached alternative or a system that they should call ahead of time. And with inference routing, we can actually kind of see what load is on the system, what type of system it's running, and then route around it. Think of it as like load balancing to either target or avoid things like nodes that are GPU heavy or systems that are GPU heavy to reduce your cost. So those are all things that, I mean, some of them one part may exist in a current API gateway, or one part may be, in theory, a part of another gateway. All of these are part of Agent Gateway. All of them exist on this platform. And so I'll do a quick demo. Not sure how I'm doing on time, but perfect. I can take questions as well. Right. So as I said, this is platform agnostic. I'm not running, well, technically I'm probably running a Kubernetes somewhere on this machine because I always am, but at the moment I'm not running it to do this. It is literally just a binary and a config file. And if I cat that, it's fairly simple. Note that this is in a container right now. This is literally just running on my machine. As a bind that's saying on port 3000, I'm listening to, basically it's almost like an echo node MCP, essentially to just give you a response back. It's a server everything. And you can add and remove things, what origins it can connect to, what you're allowing in and out. You see the chorus command there. And then you can add more and more listeners. That's all through the actual config. That being said, you can also just start up the actual agent gateway, and that exposes this locally. And you can see a few things. What ports have been bound, that's the 3000, what listeners, what routes I have, and what backends. So as you add more and more MCP tools, or you're adding more LLMs, or you're adding anything else, they show up here in these various sections, like this listener again, that's the 3000. What routes you have right now, this is just the one unnamed listener blank route, but you can add, just as I said in the K-Gateway spec, like there's a ton of different ways you can add routes and do controls and direction based off like header checking and what auth you want to do. And then what backends I'm running. So in this case, I'm just running the test MCP, and I can add whatever else I need. I mean, one of the other open source projects we have is Cajun. Often you would see in our demos, we'll set up a Cajun system here. Actually, my coworker Chris Hastig has a really good blog post on using Cajun and MCP. And then you have whatever policies you've applied. You have, in this case, it's just HTTP empty, and then you have a little playground, so you can actually connect to whatever you're testing. In this case, I don't have a bearer token because you can see it's localhost 3000. This is just a simple MCP server, and I can just run a test echo. Now, normally you can hook this into other, well, I have run some Llama stuff locally, but that kind of tends to bog down my system, no offense, but it's just a MacBook Pro. It's not, a big GKE instance I usually run stuff on. So this is all stuff that you can test right now. Again, this is all open source. We are an open core company. You can go run this now. It also produces quite a few metrics. If you're familiar with the Envoy world, some of these might look at somewhat similar. But things like, what tokens you have, what counters, what list calls you have, et cetera. So you can get a great deal of detail, and that's just the metrics. So yeah, please get involved. We would love to have more people join us. There's obviously the GitHub, there's a Discord. That QR code goes to agentgateway.dev that goes through a bunch of examples, including things like multiplexing and more kind of complex concepts. I would love some questions if anyone has any.
Yes, we have lots of time for questions. So.
Hi, I really enjoyed the talk. Thank you.
Sure.
So you mentioned that I don't know your company very well, but you said that CTO is the original contributor to Istio.
That's correct.
And did you build, yeah, sorry.
His name is Louis Ryan, and he was the co-founder of Istio when he worked at Google, and now he's our CTO of engineering.
Right, and so Solo.io is a company that is like selling Istio as a product, I suppose?
We sell some enterprise features built on top of Istio, as well as Istio support. We're like a very typical open core company. The majority of the way we sell into larger companies is we sell support, and then we have, in the case of like Istio, we have extended features that enterprise companies are more interested in that aren't part of the open source distribution.
I see. It's very fascinating. I feel like, so Agent Gateway is built on top of Istio, it looks like, right? Is it?
No, Agent Gateway is entirely its own project.
Okay.
Some of the developers that worked on Istio also worked on this, in particular John Howard. And one of the things that we've really learned while building out Istio, particularly ambient, is how powerful you can make Rust. And so some of the knowledge that we've learned from that has definitely shown here. There's something called zTunnel with an ambient mesh that does that. But this is its own project. You do not need to run a service mesh for this. There will probably be service mesh integrations with this at some point, because the way ambient mesh works, you can integrate this pretty easily. But right now, totally independent project. I shouldn't overuse that term, that you can run without anything. Literally, you don't even have to run Kubernetes. Yeah.
That's cool. Yeah, I want to check out more, definitely. Yeah, thank you.
Yeah, they're the Istio and Envoy expert, but hopefully they learned to this, make it even better. Any other questions? Yes.
Thank you. A great presentation. My question is, compared to, let's say, a typical web server, Tomcat, is this something similar in that analogy that agent gateway kind of like on top of that tier for all the communication? Because I'm trying to understand what would be the performance.
Right. So if you think about it in the same space as Tomcat, where you have like your life of a packet would be CDN, load balancer, Tomcat application. This would be, depending on how you want to route into it, doesn't have to be from external, obviously, but essentially agent gateway to agents to LLMs to whatever else. So like if you're launching it in Kubernetes, think of it as another way of routing traffic into Kubernetes. If you put it into a VM, that would be your front door as well there. Again, it's like in a similar space to an API gateway or an ingress.
Thank you.
Any other questions? We have a few more minutes. Cornelia.
Hey, what does the deployment model look like? Is it more of a standalone gateway that companies install and route traffic, or is it more like a mesh kind of deployment model where you could?
It is a standalone. You don't have to mesh it with anything. I mean, technically it's running as a control plane, so you can run multiples of these just as you would as an ingress. But yeah, it's not, you don't have to make it part of anything else.
But how do you imagine this being used when there are multiple agents running in the ecosystem? So all the traffic needs to get routed via this?
This would be the point that you would route that traffic through, yes. So, yeah.
Go ahead.
Okay, and last question. Anybody? Love it.
Great presentation. My question was that would this be something that developers integrate, and how would it change their productivity? Like, want to debug how the agent behaves, what would be the process?
So this is something that potentially your developers may tangentially be aware of, but hopefully they won't have to have a lot of work with. The idea being this is more of your overall infrastructure. I know there are talks about making a developer portal, so like backstage integrations into this, but the idea would be, you're developing your application, it needs to talk to an agent, it sees the agent as its endpoint, and the agent does the rest of the work for them. In a similar way that a lot of things that run in Kubernetes, it's like the idea is they build their service, they your developers test their service, but they don't need to know necessarily the guts of what their node is doing, right? Like that's too low level. So yeah, the idea is your developers may have some integrations into it, but they won't need to be running this on their own machine. They shouldn't need to run this to do development work either.
But my question is more focused on, like, for example, it hallucinates or it gets like a tool called wrong. So what would be the process of debugging?
So that's a good example where tracing is very important. So if you're building out an agent and you're like, hey, I'm working, so you're talking about like someone's developing an agent, right? Not necessarily a consumer of that agent. Then this would be a great tool because you can go and look at what that agent did through tracing it, right? So it's like, oh, well, I know this agent called to another agent that called to another agent, and that's the one who hallucinated poorly because I can see the response, I can see how many tokens they used. So in that case, yeah, that is a very powerful debug tool. Sorry, I misinterpreted that. When you said application developers, I immediately thought like service owners. Like, no. Yeah, people who are developing agents, they definitely should be aware of this and the tools they get with it.
Okay, thank you.
All right, let's give a big hand to James. And I'll let Dave introduce the next speaker, but I'm very, very excited because we finally have Meta here. And they have a couple people too, so thank you for coming. Dave, do you want this?
Okay, next up we'll welcome our friends from Meta. And as I said before, the AI Alliance was founded originally by IBM and Meta, and we both have a lot that we've invested in and are continuing to invest in open source and AI. One of those projects is Llama Stack, and so I'm very excited to introduce to you Kai Wu and Nikhil, and they are going to, you're all set. Okay, so I'm just going to go ahead and turn away and let you guys go. Go for it.
Yep. Thank you so much. Welcome to my talk, Llama Stack in production. The first I want to talk why we need Llama Stack. Basically, we want the Llama Stack to make it easy to build with llamas. Right? And what does it mean to be easy? Okay, for developer, the inference API should work without any platform logging. That means you can run with Llama on your devices, VM on self-hosted server, or even like firewall cloud provider. Also standard things like tool calling, streaming, multimodal inference should work out of the box. Also for providers who are serving our Llama model, especially for the new models, they want to serve with confidence. They want to make sure that all the things are configured correctly. Also, for those who actually want to serve it on-prem, they want an easy setup and a test solution. Also, it's easy beyond inference because we all know inference is not enough. Right now, for developers, they definitely want to have production-ready agentic workflow, like tool calling, knowledge retrieval, safety, and telemetry. Also, a lot of time, people use Llama. They want to fine-tune the Llama with their own data, and they want to do the post-training and the evals. We want to really reduce the complexity of it. Also, for provider, they want to offer more than just inference. They want more for agent, tool calling, and also fine-tuning abilities. And then for the on-prem, actually, they have to handle all this complexity stuff, which actually I will talk more about this in the demo. So our proposed solution is actually use API. On top, for the provider, we will have a CLI, we will have SDK, and we also build our own interface for them to use Llama and tune Llama. On the bottom, for the partners who want to serve Llama or do their own basic stuff, we will give them this package distribution. And the Llama Stack actually supports the full development lifecycle. For example, you build the agent, you can use like agent API, memory API, inference API, and a safety API. For deployment, telemetry will definitely help to monitor.
Also, if you want to run eval, we have like a data cell that can load Hugging Face data set. We have this eval benchmark to test, and also the scoring to scoring your agents. Similarly, we have post-training that can fine-tune your model is coming, and also the synthetic data generation, also batch inference to really help you improve your model. We have defined the API and integrates with many providers. For example, the inference here, definitely the Llama, VLM, and famous other cloud provider. Also, we support iOS and Android. We have that SDK as well. For safety, we have like Llama Guard. For post-training, we can use TouchTune, Hugging Face, and yeah, so for scoring, we have like those basic function, and we also have LM and judge. And yeah, we have tool calling, we have MCP support, vector database, all kinds of support over here. And the one thing we provide is Llama Stack CLI. It's very easy. Once you have your Llama Stack server, you will get an endpoint, and you configure your client to that endpoint. Then you can just do like model list to figure out what model you are hosting, inference check completion to take it to the check completion, and you will get a response. We will also provide SDK. Two common one is Python and TypeScript. Similarly, just connect to the endpoint, check completion, get a response. Very easy to use. And also we have integrate with tool execution with the agent. So basically you have your client, and then you build an agent class to specify what model you want to have, what's your instruction, and what tool you want to have. And the agent can create a section, and within the section you have multiple terms, and all this section history will be managed by Llama Stack as well. Also for the provider or for someone who actually want to do your own fine-tuning, we have Llama Stack Eval that can reproduce our model card benchmark. Some provider want to do optimization like quantization or spec decoding. They want to make sure it's correct. Also, an individual who want to add their own data, but they also want to see if this model is good for production. They may want to run if eval to make sure. Also, we have provider verification. That basically is double checking if the API provider has been hosting our model correctly. We will test like all the things like streaming, structure output, tool calling, multimodal inference, everything, and give you a report whether you are hosting our model correctly. And so again, Llama Stack, we support standardized API. We will lean on the industry like soft standard when it's applicable, like OpenAI capability and MCP. We will also making new standard like a safety, retrieval, eval, fine-tuning. Basically, the goal is build once and deploy everywhere. Like imagine you build on Llama, you can deploy on VLM, also even on your phone. That's basically our goal. And we provide CLI, SDK, and package distribution for that. We also have the test suites, and that include like the benchmark evals and the functionality verification to make sure you are getting it correctly. And we are actually OSS first, so it's definitely an open source project and platform agnostic. That means everything is open source, everything is supported on VLM, even the latest model that released today, we support it. Okay, so back a bit on the on-prem thing. I want to talk about, for example, how we collaborate with Dell, and potentially we put it into production. And so Dell has its own hardware called Dell AI Factory. That's their hardware box. On top of it, they can host a Llama Stack container, and Llama Stack container actually have those API adapters. They can pick whatever they want, right? So if their customer has invested a lot on the PG vector, they just choose PG vector. If they prefer NIM, they can choose NIM. So whatever they have. So MCP also, they can build their MCP server and also connect to what the remote as well. So, and on top of it, we have the app. This app could be like a multimodal RAG, color search, that can be used by their user. So their distro is actually just defined by a YAML. It's very easy. You just literally switch, like this one, the Dell Enterprise TGI here, and they have the Chroma DB, they have loaded the Hugging Face data set, they use Llama Guard, everything is meta reference, but it's very easy to just switch by changing this YAML. And our vision is that you have everything in your box. So basically, you have our distribution, you have your standardized API, and of course, you can build your own. Also, you can integrate with all kind of apps. For example, Continue, Onyx, DeepSet, AnyCLM, and then put them in the box, either pre-install or like installed very easily. And you can have an app suite, and whoever client wants them, they could have like a coding solution, customer support solution, knowledge search, and a personal assistance. Okay, finally on my demo, so I will quickly go through this diagram, basically saying what I'm just set up here. In the middle, we have the Llama Stack server that basically connects to everything. We use, for this demo purpose, I use a lot of provider just to show. We use VLM, for example, for the chat completion. We use NVIDIA NIM for the code completion. Actually, VLM did not support the fill-in-the-middle code yet. So we use Llama to host like a safety model, and we use Postgres to store the metadata. That's all the agent section, all the agent history stored here. We use Chroma DB to get all those RAG. We use Yager to the telemetry. And we also, inside of it, I use the inline sentence transformer just for the embedding, a very small one. And on top of them, I could have a premises that's for the metrics collection. And those metrics can be actually rendered in the Grafana dashboard. One thing I haven't implemented is the auto scale. Potentially, you can use all those metrics, like your GPU metrics or like the latency from VLM, to scale up and scale down. And now we have this Llama Stack server connected to all components. And then it will be connected to our Llama Stack UI. Inside of this UI, we have the client that can register MCP server, for example, remote one. And also it can power external LLM as well. So yeah, so let's see. So the first, I don't have time to set up the whole thing because just getting the VLM running is taking 10 minutes. So I quickly just show you here. Basically, I have all those YAML, and you need to install the NVIDIA operator. Oh, maybe I should get it on. Operator, and you need your Hugging Face. You need your NCG to get the NeMo working, and basically just apply the SH, and everything should run up. Okay, let's first check my UI. I have the API key, I just save it. Let's see what I have here. Yeah, for the inference, again, I have the remote VLM, remote NVIDIA, remote Llama for the safety, and inline sentence transformer. For the vector DB, I have the Chroma DB pod running and registered. Safety is a Llama Guard, and agent, as I said, I have the Postgres. Telemetry, also the Yager, and also the tool. We have several built-in tool, search, RAG, MCP. Actually, the first thing I want to do very quickly is to register my MCP. Yeah, because this one is public and I don't need any key, so it's already registered. And another thing I want to do, okay, yeah, I want to show you all this model that I'm using. We have this for embedding, the stakeholder for coding, 1B for safety, and a 70B for the chat. And hopefully, I will quickly just get this set up. Basically, I just use the text from our page, and I just upload It should be very easily uploaded. Okay, let's verify if it's here. Yes, it's here. And then I go to the tool. I need to use the 70B. Let's just do simple rag who will give talk on Llama stack. Actually, just FYI, I hope this works. Okay, of course. Because I forgot to select the vector DB, sorry. You will talk on Llama stack. Yeah, it should work. Yes, that's us. Also, like web search, one is the AI agent SF Meetup number 5, I believe. Yeah. Number 5, hopefully it work. Should be today. Yes, yes, it's today. And of course, I have the MCP here. You can see they provide 2, 1, and I just say, what is Cloudflare? It should work as well. And we have like a regular one. Also, we have the React one. It's really easy to use. Okay, that's basically just some simple UI for you guys. And oh, maybe I forgot to mention that I have this dashboard. So potentially you can see this GPU utilization, it has been peaked, and use those metrics to scale up, scale down. One more thing I want to show you is a continue. Actually, let me pull it up. So for example, continue is an open source plugin for the coding, and we have collaborated with them to get it down. It's as simple as a provider. So I have this config, I'm using this as coding. Hopefully I can just code, multiply A and B, and they should be able to give me auto completion, which is great. And let me see, create task cases for simple calculator. Okay, let's see. Okay, it's taking some time.
Even AI doesn't like to write tests.
Yeah, it doesn't like. Oh, okay, something going wrong. Let's see what's going here. So I haven't introduced with this tracing, and actually we can find out what has been going wrong. So this potentially is my last call, and I can see that my message user, oh wait, why they are putting all the special token in the user? They should not do that. So, and of course, this I know that it's going to get it wrong, but it's very simple fix. There could be something I need to fix, but if I just call OpenAI, this should work. But yeah, I want to show this telemetry. I want to show this bug and how easy it is to use our telemetry to actually see what has been parsed through Llama stack. So that, you can debug it very easily because everything here, what I just do, like completion, agent, two group model, everything has been shown up here. So it's very easy to debug. Yeah, once I change it to OpenAI, everything works, and I just apply, and it should be, oops, sorry, I should not apply on this. Anyway, yeah, it's having some problem. Yeah, that's all for my demo. I will back the floor to the partnership.
Thank you, Kai, for the awesome demo. It was great to see all the tools working without any errors and the debugging steps. I'm Nikhil. I'm a product manager at Meta. I'm also a member of the AI Alliance. And so we recently set up a collaboration between AI Alliance and Meta's Llama stack. And we're supporting that as an official project. So I'm leading a project at AI Alliance to build on Llama stack. We're building reference applications and demos and use cases for customers. So this is really an invitation for anyone here who wants to collaborate with AI Alliance and Meta. You can use this thing here to fill in your info or come reach out to me. I'll be here after this thing. We have networking. Come reach out to Kai, talk to us. Things we're looking for. One, if you are interested in deploying something with Llama Stack in your organization, we'd love to learn more about that and see how we can partner with you. If you're interested in contributing to some open source projects like building reference applications or demos for Llama Stack, or even just like learning more about how it works, you are very welcome to come join our working group. Again, like come talk to me about it, and you can learn more about opportunities. And yeah, you will have the opportunity to learn, to contribute, and to provide feedback to shape the product roadmap potentially in a way that works better for you. So, okay, that's it for our talk. We'll take questions and we'll be around to chat later. I'd love to hear from any of you who are interested.
Yeah, we have time for a couple questions. Anybody have any questions? All right. Okay, in the back there, hold on 1 second.
Yeah, go for it.
Thank you for the good, this is wonderful. Surprised not more of this type of framework is out there. And without getting you folks in trouble, are you guys eating your own dog food at Meta, doing this internally at all, this Llama stack?
Yeah, definitely. We have been using and building apps. We have like a Llama Stack apps, and that's kind of repository for our app. Also, I think it has been used a lot by the Red Hat. Also, even the Oracle Blueprint has a deployment. So yes, a lot.
Okay. Any additional questions? I liked how you misspelled Cloudflare, but it still actually figured out the answer. That was pretty cool. You had a question?
Oh, yeah. Are you guys working on anything in healthcare specifically with your working group? And I'd be super interested in collaborating and maybe even building some base projects. You know, I've been building healthcare for 10 years now, and unfortunately, a lot of these startups that are coming out that are doing AI in healthcare have zero experience launching, you know, mission critical software essentially. I'd love to.
I'll give you a very short answer, which is that please come talk to us after this. We'd love to collaborate. And like currently in our group, we don't have a healthcare use case. I can't speak to like, there are many other groups building open source applications on top of Llama Stack. But if this is something you're interested in and you have a use case for it, let's talk. You're very welcome to come build with us.
Amazing.
I think there was one more question.
Oh, yes, I do. I see the hands. Okay, hold on. Will the slides be available? Yes, we will make the slides available. Okay, one last question.
Thank you. My question is, so it sounds like this is the tool to build one of the agents, right? You set up the MVP and MCP and all the supporting. So my question is, if I need to do multi-agent, does it mean I have to manage that beyond this what Llama Stack can provide it? And also, in addition, if I'm doing this in the Bedrock AWS system, how would that impact on how would my engineer will deploy this? Thank you.
I think multi-agent is still on the roadmap. Definitely, we are working on it. For now, potentially you can do both agent and you just pass the response, for example, as a string to each other. But how you manage the section is something we need to work on. The second one is AWS Bedrock. I think the inference, definitely you can use whatever, like a VLM, and database. I think as long as, let me think, you have the inference and you could have everything in EKS, right? And potentially you can use Kubernetes to handle stuff as well. Yeah.
Okay, I think we should move on. So thank you very much for your presentation. And a reminder, they will be, I think you'll be around afterwards. Okay, so if you are interested in bringing a use case to them, I want to particularly highlight one use of Llama Stack that I've identified, which is if you build a software application that you want to sell to a company to run on-prem, and you're building an AI application that needs some sort of LLM, a vector database, maybe some telemetry, maybe some eval tools, and you go to sell your solution, if that enterprise already has similar tools that they've purchased and they support, they may not want to support and purchase the tools that your application needs, right? So now all of a sudden they might like your application and they might want to buy it from you, but you're telling them they have to go purchase these other 5 applications in order to run your application. But with Llama Stack, if your software solution runs on Llama Stack, and Llama Stack also supports the additional software tooling and infrastructure that you already paid for, now Llama Stack just unblocked that sale because they can use those APIs to use those other software solutions. So I find that very valuable. Okay. Oh, you're already there. Here you go. Oh, yes, of course. Here you go, Max.
So it's a pleasure to introduce the next speaker. So of course, this is the last speaker, and after that, we'll have some food and networking, as you mentioned. So I spent about 5 years, I think, working at Pivotal. And if you remember, Pivotal was one of those companies where people spent time pairing. If you've never paired before, it's like working with Cursor, except human. Different levels and humans. So that's the big difference. But anyway, it was a great time, and I pretty much paired with everybody. And sometimes really good people, and sometimes not. But then every now and then, we would get people from the second floor come and kind of tell us what's next and what's coming. And Cornelia was one of those people. So she was a brain trust at Pivotal, and she's going to tell us what she's been doing since at Temporal, which is very exciting. And she had an announcement this week, so tell us about it.
Yeah, you bet. Max, thank you so much. It is such a delight to be reconnected now. Thank you so much for being here, and thank you so much for having me. I'll try to stay in the mic here. Quick intro to go beyond what Max said. So yes, I spent a lot of time at Cloud Foundry. I was at Pivotal from the very first day Pivotal was a company. I came there from EMC until the very last day when they were acquired by VMware. One of the things that happened during that time period was kind of the boom of where cloud native really started happening, microservice architectures and those types of things. So I feel like I already hit the lottery once in my career, being at the forefront of this big revolution. I spent so much time doing this that Manning approached me and asked if I wanted to write a book, and so I did, and I'm not sure that I would recommend that. So the agenda today is that I'm going to talk about the OpenAI Agents SDK. And I will tell you more about the announcement in just a moment. I work for Temporal, so I'm a developer advocate at Temporal, and I will tell you about Temporal. So first, let me ask a couple of questions. How many folks are familiar with the OpenAI Agents SDK? Okay, so about 20 people or so, maybe 15% or so of the folks. And for those of you who don't know, there's Python and TypeScript as well. How about Temporal? How many folks are using Temporal? Not very many. So I think a lot of you are not familiar with Temporal. You will be far more familiar with Temporal by the end. And then really, and I'm going to give you an intro to both of those things, but then we're going to spend the time talking about the better together, because we do have an integration between these two, and you'll understand why that is in just a moment. Now, there's that fourth thing on there that doesn't seem like it fits, human in the loop. I'll ask another question. Human in the loop, is it easy in agentic systems? No, right? It's human in the loop can be really tricky, and I think that you're going to see that this combination offers something really interesting in that space. We're going to do tons of demos through this. I am a believer of pictures, 1,000 words thing. So I'm going to show you some pictures. I think there's very few words on these slides beyond what's on the pictures, and we're going to do lots of demos. So starting with the OpenAI Agents SDK, we just saw something that looked an awful lot like this from our friends from Meta just a moment ago. So what it does is it allows you to define an agent, almost declaratively, if you will. You can see here that you define an agent as, and this is in Python, you give it a name, you give it a model, so each one of your, there's a default, but each one of your agents can be running in different models. So we've heard a lot of that about that arbitration tonight, about how we want to use different models at different times for different things. So you can do that here. The instructions, that is the natural language stuff. That is the context. That's the context that seeds the agent and is telling the LLM what the LLM is, essentially instructing the LLM on what this agent's supposed to be doing. And then, of course, it has the ability to call out to tools, and I'll show you the agentic loop in just a moment. And then they also have something called handoffs, and we're going to talk a little bit about orchestrating agents in just a moment. Now, if we take this, there's a little picture that goes with it. Let me just blow up that picture a little bit, and I'll tell you about all of those things again. The first thing that I'll tell you is that the agent, that object that we were just looking at, and by the way, this is an SDK. It's just a library. It's just a Python library. That's what we're talking about here. So that agent object has embedded in it an agentic loop. So it has an LLM at the core, and then it automatically has a loop built into it. The things that you can do in the loop is you can make calls out to tools. That's what you see on the right-hand side. Again, you can see all the attributes that I showed you in code here. You can see that the model is part of the LLM there. You can make calls out to tools. You've got instructions that seed this. So, of course, the instructions become part of the context that goes into the LLM. And then it's kind of hard to show in this diagram. I did my best to say that a handoff doesn't actually give you a new agentic loop. It's the same agentic loop, but if you will, you're taking the agent, and the agent is kind of shifting its identity. It started as maybe one thing, and that now you've done a handoff to something else. And I'll show you a concrete example of that in just a second. So here is a great example of handoffs. So I could have an agent that is a question answering agent. And I didn't tell you, but I spent a year and a half on Alexa as well. So I sometimes use those use cases. So if you ask your Echo device, your Alexa device, hey, what's the weather? It's going to give you a weather answer. And if you ask, how late is Costco open? It's going to give you some local information. So the agent in this case is a question answering agent. And the first thing that it's going to do is it's going to take in the user input, and it's going to use the LLM to figure out which handoff it needs to do. So the LLM is a great thing. And by the way, when I was at Alexa, we didn't use LLMs. This predates that. So we used things like patterns and templates and things like that, which kind of explains why your Alexa device doesn't work all that well. But we use the LLM. The LLM figures out, oh, this is a weather question, and it morphs the question answering agent into a weather question answering agent. Or if you're asking about, Costco opening times, then it morphs itself into that type of an agent. That's what handoffs are for. It basically allows you to stay in that loop, but morph into a different agent. Now, one of the things that you might notice here is, and I'm going to start using this term, is that the model here with the OpenAI Agents SDK is really one of building a whole bunch of what I'm starting to call micro agents. a bunch of smaller agents that do one thing and do one thing well. And I think we're starting to see that happen in the industry. We're starting to realize that as the smaller scoped we can make our agents, the better they perform, because we can give them very detailed instructions. So the model here is that we're going to create these micro agents, and then we want to orchestrate them. So here is a broader picture. We might have something where we want to triage, and you'll see some of these use cases later. We want an input coming in, user input comes in. We want to triage that and figure out, do we need to ask the user for more information? You see the little human in the loop. We'll come back to that in just a bit. And if we do, we ask them more questions. If we don't need more info, then we go into instructions and it flows along. So here what you can see is that we have a number of different agents. We have a triage agent and an instructions agent. And then, and I talked about the agentic loop. That loop kicks off anytime you're doing a runner. So anytime you do a runner.run, and there's ways of doing it synchronously, asynchronously, all of those things. I just showed sync here. What we do is we invoke an agent. We can take the results from that agent, and then we can orchestrate and hand that to another agent. Feels pretty familiar, right? It's like orchestrating microservices, but we're orchestrating these micro agents. So you'll see why these things, where handoffs and orchestration comes in. And then to take this flow and continue it on the right-hand side after we do the instructions, these types of orchestrations are really important because it allows you to have full control. The example on the left-hand side had this tricky thing with human in the loop, right? Human in the loop is a kind of hard thing to do when you've got these autonomous agents. How do you inject that into the flow? Another thing that can sometimes be tricky is these fan out. So I want to actually fan out to a bunch of micro agents, have them run in parallel and fan back those results. So there's the thing about the OpenAI Agents SDK is it has some simple abstractions, but you can orchestrate these things and you can put whatever control flows you need in there. And I'll show you a more complex, even more complex one in just a minute. So let me jump over to a demo then. I promised you lots of demos. So I'm going to come over here and I'm going to show you the simplest code. So right here you can see that this is the Hello World agent. And so the agent has just a couple of attributes. It has the name, which is it's an assistant, and the instructions. So this is the context that goes into the LLM, along with the user input. It says you only respond in haikus. We've all seen this. I love using kind of standard demos. And then you can see here that it does a runner.run. And then it prints the final output. So let's go over and just run that. It reformatted. Let me get should have brought my glasses up here. I think I'll manage. Okay. So I will explain what I just did there in just a moment. Let me go ahead and find there it is, Hello World. So the user input here is tell me about recursion, and if all goes well, there we go. We get our haiku, code calls itself back, solutions build in the loop, infinite echo, and I cannot help it, haiku, here is my code, run it in the cloud for me, I do not care how. So those of you who know Cloud Foundry, you know that was Unsie's very famous haiku in the Cloud Foundry space. So pretty basic stuff. So it works, it runs, and that's what I'm running. I'll come back and I'll make that more complex in just a moment. Okay, so that's the intro to the OpenAI Agents SDK. Let's now talk about Temporal. So Temporal is the company that I work for. It's an open source technology that does this. It allows you as the developer to program the happy path. That code that I just showed you, you notice that there were no try catches in there. You notice that there were no retries in there. There was nothing. It was just my happy path. Here's my agent and run my agent. Okay? So what Temporal does is it allows you to write your code with the happy path. And all of those things that you need to do for distributed systems, so my book that I wrote with Temporal, some of that's obsolete. Because in my book, I wrote about retries, and I wrote about circuit breakers, and I wrote about pub sub, and I wrote about having a backing store that you use for state preservation and stateless services and all those types of things, well, Temporal just delivers that for you as a service. So I want to introduce to you two primary abstractions. This is not a full Temporal course, but there's two main abstractions. Just like I showed you what the agent was, I want to show you what the main Temporal abstractions are. We have something called an activity. Activities are just things that you're going to do, things that you need to stitch together. So withdrawing from a bank account is an activity. Depositing into a bank account is an activity. Now, these things can be scary. Things can go wrong, right? I could have a network outage, or I could have the API could be down, those types of things. And so these are activities. And then when you stitch them together into a full application, you do that with a workflow. So the workflow orchestrates your activities. Now, the cool thing is that, and we have an SDK, and I didn't mention it earlier, but let me mention two other things. Temporal is available in 6 or 7 different languages, so Python, TypeScript, Golang, Ruby, PHP, .NET, Java. I think I got them all. And it's fully open source, MIT license, not open core, open source. Everything is in the open source. Okay, so what we have here now is this orchestration. And when I code this, and I'll show you the code in just a second, I code the happy path. I still have to put error checking in there for things like the account number didn't exist. That's an application level error. You still have to handle those, but you don't have to handle the distributed systems errors. And what we do is we take that and we, Temporal, add all of those things. We will add in retries around your activities. We will introduce queuing in between the different steps. We will manage state and watch how far along you've gotten in this progress so that we can pick up where it left off if something goes wrong. Okay? So that is the most basic intro to Temporal. Let me go back to demos here. Oh, in fact, I was going to show you, oh, where did my, hang on. Oh, there we go. I am going to show you just the code. That money transfer application is kind of our canonical application. And again, what you can see here is that the workflow is defined in Python. We just add a couple of decorators. So we have a workflow decorator. In my activities, I have my activity decorators. And then the orchestration back to the workflow is pretty straightforward. I'm just going to withdraw money. I'm going to deposit money. If something went wrong with the deposit, then I'm going to do a refund. Pretty straightforward, just happy path code. All right, so now back to that simple example that we had. I'm going to go back over here. And I'm going to do something. I'm going to throw a wrench in things. I'm going to break my network. So I am going to enable a firewall here. If I can type in my password. Okay, looks like it worked. So I've enabled a firewall rule here, and I've blocked access to OpenAI. That's the LLM that I'm using in this particular demo. So I'm going to run this again. And now it's going to sit there. Now let me come over here to what is the Temporal UI. So here's the Temporal UI, and in running that workflow, what you can see here is I can drill in, and you can see that the workflow is running, but this invoke model activity here that we see, notice that it's red. Before it just finished, but it's red because right now I have a firewall rule that isn't allowing me to reach the OpenAI endpoint. So let me disable the firewall. And if we come back over here, bingo, it turned green. So what we did there, and you'll notice this is the exact same code that I showed you before. I'll scroll up a little bit. You can see that it's running within a workflow. So because it's running within the workflow and using the Temporal SDK, it recognizes the agent and says, okay, well, I'm going to do some error checking and some reliability. I'm going to add some durability to this. So no retries implemented here, except that when we look at the temporal UI, that we can clearly see down here that it says attempt 5. I reattempted that 5 times. Now I want to show you one other thing, and that is where it gets really interesting, is I'm going to enable my firewall again. I'm going to run this. And this is running in temporal, and down here in this bottom window is where I'm running temporal. That's where I'm running that workflow, is running in that lower thing. So I'm going to crash that. So it went down completely. So that application that has the retry in it, that application is gone. Now let's go back over to the temporal UI. We'll look inside of that workflow. And here we go. We can see that I was on attempt 4, and nothing's going to happen because you know what? The app crashed. The app is down. So let's say Kubernetes comes along and it says, oh, you lost your instance. I'm going to regenerate that instance for you. And so that's what I'm going to do here. And where did I'm going to restart the application. And so those of you who might have used like your own retries, or you use something like Spring AI, those retries are in your process. But I just killed the process. But you know what? The retry survived it, because the retries don't happen in the process. The retries happen as a part of the temporal service. Okay? So the democods might not be smiling on me because it's let's see. It looks like there's still some kind of an error, so we will just chalk that up to the demo gods. This did work earlier. Okay, so I'll just restart that and we'll see if it comes back. So I want to continue on with the presentation because the real punchline is in this OpenAI Agents SDK. So temporal, the thing that I will tell you about temporal, cool, looking at the clock here. The thing I'll tell you about temporal is that temporal is technology that predates the LLM craze that we're in today. So temporal was built for distributed systems. So it can be for microservices orchestration. It can be for asynchronous processing at the back end. It can be for any wide range of distributed systems problems. What are AI agents, if not massively distributed systems at even bigger scale than we saw in cloud native apps in the last 15 years? Because it's happening in a loop. It's just happening over and over, and we're going from agents down to agent and all of those things. They're massively distributed systems. And I once did just a little back of the envelope calculation and made some simplifying assumptions around like, okay, if I've got 100 downstream requests and each one of those endpoints claims 4 nines of availability, and the network is stable, which we know it's not, by the time I get up to the root of those 100 API calls, I've lost 2 nines of availability. So durability is absolutely essential for these agents. And so that's really what has happened is that, and you know what, I have to admit something. Our customers started saying, whoa, we're going to use this for our AI stuff, even before we woke up to that. They were the ones who came to us and said, this is really working well in our early experiments and those types of things that we're doing with LLMs. So this is kind of the picture, is that notice that I had overlaid like retries and queues and state management on the diagram. The way it works is that temporal is a service. Think of it as a backing service that provides all of those things, even things like timers and all of those things. And we won't go into all those details today. All right, let's put the pieces together. You already saw a little bit of this. So remember that I said activities are just the things that you're going to call. And they're often the scary things. They're the external calls, like downstream API call, or I'm going to access my database, or I'm going to check something on the file system, and those types of things. Really anything that might be a little squirrely for you to reach, and things that you don't want to have to redo. Things that if something goes wrong, you don't want to have to redo that. You know what's at the top of my list of things that I don't want to redo? Burn through my tokens, right? I just burned through a bunch of tokens, getting 90% of the way through my agentic experience. If that agentic experience goes belly up and I have to restart it, I don't want to run 90% of my tokens through again. That gets pretty expensive pretty fast. So things that you don't want to do again, well, what are some of those things? I keep talking about agents or distributed systems. Well, what are those distributed systems calls that you're making? Well, you're making calls to LLMs. You're making calls to tools. You're making calls to agents. Agents themselves have this agentic loop in them that are making some of those downstream requests. So here's the punchline. Here's what we're doing with the integration. Remember I showed you those agents? What we have done in the integration is that every single one of those agents is run as an activity. So now you see why I spent so much time telling you about activities and how activities have automatic retries against them. We automatically preserve the state coming back from them. Those are the things that we're doing. And so if we now, these are agent orchestrations that we see here. So most of these things, there's a triage agent, and I'm going to run this in just a moment on the left-hand side there. There's a triage agent. It goes to a clarifications agent. If we need to, we talk to humans in the loop. Then it goes to an agent that sets up some instructions. Then it plans. Then it does web searches. This is basically deep research, right? Then it does some writing, generates a PDF at the end. Most of those boxes are these micro agents, and we're going to orchestrate them in a workflow. On the right-hand side, one of the things that I really want to point out to you is that that looks like a pretty linear flow on the left-hand side. Sure, it's branching out in parallel on the search, but on the right-hand side, that is an orchestration as well. What we're doing is, let's say we go from planning, we put together a plan, we start to do our searches. It's the same thing as over there. And during the search, we realize, oh, we need to dig deeper on a particular topic. So I'm going to ask the LLM to say, okay, as I get back the search results, do we need to dig deeper? And if so, we'll loop back and we'll ask it to continue doing web searches deeper and deeper. So in this particular case, it's not a pre-prescribed flow that we're going through here. It's actually the LLM is driving the flow on the right-hand side, all implemented through an orchestration and a workflow, all durable because you're using the workflow. Okay, so let's go to the big old demo, and I'm doing good on time. I am almost done. So what I want to show you here is a couple of these agents, just to give you context. So I talked about the triage agent. So what you can see here in the triage agent is you can see that it's an agent. You can see the model it's using. The prompt up here basically says, hey, when you take in the user input, see if you need to ask the user for any additional information or if there's enough there for me to do some deep research on it. And it's telling it how to route. Remember I talked about the weather and the local info, that handoff? So this is all about kind of the beginning. It's just kicking things off and setting things up. So that's the first role. That's the role of the triage agent. And it's going to do a handoff to, let's say, the clarification agent, or there's really no clarification needed. Another agent that we'll take a look at real quick is the planner agent. So you can see here that, again, it's fairly straightforward. It's going to be doing web search. And in fact, I want to do the search. I want to show you the search agent. Notice that the search agent is actually making calls down to this web search tool. So that is a downstream call as well. So we've got all of these different micro agents. And over here, and I won't go through all of the code, but right here you can see a part of the orchestration code that puts these things together. So here you can see, for example, you can see a comment around the clarification result. It talks about the search plan and the search results and the report. So those are all those different things. And if I were to take, if I go to, oh gosh, I need my declaration here. So you can see here in plan searches, it's just doing that runner.run. So it's creating its own little agentic loop, but then we're orchestrating a bunch of these smaller agentic loops. All right, let's go ahead and run that now. So I am going to hope. Oh, you know what? Hang on, I can't help myself. I think it might have finished. Nope, it failed eventually. So, okay. So we are going to run. I'm sorry? Oh, yeah, thank you. That is why it never came back. Thank you. So it eventually timed out, is what happened. I thought I did that. Thank you so much. I really appreciate it. Okay, that wouldn't have gone all that well. So we are going to run this interactive research agent. So it's a bunch of micro agents, but they're put together into a bigger, broader agent. And I'm going to ask it to tell me about quantum computing. Okay, so I have a little a confession to make. Let's go back here, and we're going to start seeing that workflow run. And you'll notice that it's initiating the research and so on. When I ran this demo at a different event last week, when I asked about quantum computing, it said, oh, let's have some clarification. I changed nothing about this demo. And now I'm asking about quantum computing, and it's like, we're good. I'll do the research for you. It's not asking for clarifying questions. I'll show you another question in just a moment. But I want to show you that whole orchestration happening. And so what we see here is, and don't worry about the font here, but if we scroll down, you can see at the very beginning, we took the first couple of steps. So we had a triage agent, then we did some planning, and then we went into these parallel searches. Now, I could have enabled my firewall here, and you would have seen some of these retries. I'm not going to take the time to do that. I think you probably believe me because you saw it happen earlier. But we see all of these parallel searches. Some of them are still going on. Once all those parallel searches come back together, then we're going to consolidate all of those things, we're going to write a report, and then we're going to generate the PDF. Okay? So you can see how this was orchestrated. Now, the other thing that I want to show you that we did as a part of this integration is we also integrated into OpenAI's tracing system. So this is the OpenAI platform, and I'm over here in the logs area, and so I can show you all of that information in OpenAI's tracing format. So here you can see that the triage agent ran, and then a research instruction agent ran, the planner agent, search agents, a whole bunch of search agents, and so on. So I can click down into this, and by the way, this was the assistant that ran earlier. I can click down into this, and you can use the OpenAI tracing system to trace through all of the details that's happening within that agentic loop as well. So each agentic loop is done durably, and then within those agentic loops, you can drill down into the details here. So the last thing that I want to show you, the last demo is, oh, it's still thinking. So let's see, did I have any more pictures that I wanted to show you? I'll come back to that. So you can see, if it crashed now, and I had to start that whole thing over again, I would want to do that all over again. I would want to be able to pick up where I left off, and that's exactly what would happen with Temporal. I'll mention the other thing that we do is we also, as a part of the integration, and I'm not going to take the time to demo it tonight because we're running a little short on time, but we also have the ability to take temporal activities, and with a simple call out, and I'll actually show you the code on that, you can take a temporal activity, which is already designated as something that's going to have retries and all that resilient behavior around it, and you can just make those tools. And I'll show you that in just a second. So let's go back to that final demo. And indeed, it came back and it finished. So just to see that, here we can see that the final thing finished. But I want to show you the human in the loop because it's pretty darn cool. So if I come back here, and I'm going to run that again. But this time I'm going to say, tell me about physics. It's a little bit more general. Physics, okay. And now what it's going to do, unless something's changed, so you can see the user experience here is that when it went into the clarification agent said, that's too broad. That's way too broad. And I'm going to ask the user for a few more questions. So I'll answer those and say, classical, mechanics. I never did like E&M, but I loved mechanics. So we'll do that. We'll do basic concepts. And by the way, that clarification agent, I can show you the instructions. And by the way, I'm going to give you QR codes to this code. All of this is available. You can all take a look at it. So let's do basic concepts. We'll get it started. And nope, nothing else specific. And so now it'll continue doing that. I lost my train of thought. Hang on, it'll come back. We gave the answers. I'm sorry, I'm hearing somebody. What's that? It's okay. It'll come back. It'll come back. So what we're doing here, I'll come back to this, and I'll show you what happened. So here it's running, and you can see that it's doing the searches. We had those before. But if I scroll down, what you see here, and I'm going to just step away from the mic for a moment, is provide single clarification. What we've done there is that we have the agents running, but at certain times we pause. And the whole orchestration just pauses, and it waits for a signal coming from the output, coming from the outside. That's another one of the key abstractions of temporal, is that you can have workflows that run. We have customers that run workflows for years. Super interesting use case. Come find me during the social hour and I'll tell you about those. But of course, if you're going to run this for years, you want to be able to interact with it. You want to be able to put more info into the running agent, or you want to be able to get information out, query the status and those types of things. So what we've done here by running these orchestrations of these agents within a workflow is that we've lent to it a standard abstraction that allows you to interact with that orchestration, interact with the agent. And that's what you see running in here. And that's exactly how it works. So remember I said that we weren't built for AI use cases? But all of these abstractions, workflows, activities, queries, signals, updates, all of those things turn out to be exactly the things that we need for agentic AI. And that's why we have integrated with OpenAI. They're super and supportive of our integration. We didn't do this on our own. We did it in collaboration with them. So super excited about that. Okay, that is my last demo. So let me just give you the QR code slide. Yeah, we just did human in the loop. So here's the QR code slide. There's 3 things on here. On the far left-hand side is a blog post that describes what I just went through in this talk. So it describes how we made these things durable. The second one is a demo video that is like a 12, 15-minute video that basically goes through the demos that I just showed you. And on the far right-hand side is the GitHub repository. So totally invite you to come take a look at that. Again, I'm in developer advocacy, so join us in the community Slack. Would love to hear from you there and would love to answer. I think we maybe have a minute or two for questions.
We have time for a question. Thank you, Cornelia.
All right.
Thank you. See if we have another question from somebody else. Anybody? No? Lawrence?
Hey there. I love Temporal. I mean, I've used it at my past gig and current gig. So I have a really quick question is, why did you pick OpenAI agentic SDK? Is it, I mean...
So I'll answer a slightly different question, which is, that's not the only one that you're going to be seeing us integrate with. We have a great partnership. I can be a little bit public about this. So OpenAI themselves use Temporal in their solutions. They've been very public about a couple of them. So the image generation that they released just a couple of months ago all runs on Temporal. Codex runs on Temporal. And so we already have a very good relationship with OpenAI, and so it was natural. We had these different technologies that were coming together, and so that's why we started there, because we already have a great relationship with them. We have great relationships with some of the other folks as well, and so you'll be seeing more of these types of integrations coming out.
Cornelia, I won't say it, but OpenAI is a leader. That's admit it.
They kind of are the market leader, yeah.
Any last minute question? Pizza is here.
I'm going to
Take one
stick around, so if you want to come find me, I'll answer more questions too.
Thank you again.
So, thank you.
Thank you, everyone, and please come back and join us again next month. First Tuesday, same place. Thank you.
And you got, broad, and you got deeper and deeper.
Yeah.
And some of your demos didn't work. That's okay, because it's real, right?
Yeah, exactly.
And,
I didn't.